Namaskar. You are listening to Vigyan Ki Awaaz, a podcast series brought to you by Media for Community Foundation, supported and catalyzed by National Council for Science and Technology Communication. On Vigyan Ki Awaaz, we bring to you the latest innovations in technology and science from around the globe. We also get to you the latest from Indian labs working relentlessly to improve the quality of your life. India's Council of Scientific and Industrial Research, National Aerospace Laboratories, has showcased a scale model of a new variant of its Saras multi-role commuter aircraft at Aero India 2023, being held in Bangalore from 13 to 17 February. The Saras Mk2 features a high wing and turboprop engine mounted on wings in tractor configuration as opposed to a low wing and pusher engine configuration on the baseline Saras. The new variant, which also has a pressurized cabin, is indigenously designed to meet the Indian Air Force's troop transport requirement. The aircraft is intended to serve both civil and military purposes. It provides regional connectivity as well as capability to transport cargo and troops to high-altitude areas. As per UNI News Agency, CSIR, National Geophysical Research Institute, a constituent research laboratory of the Council of Scientific and Industrial Research in Hyderabad, organized a 4-day 34th Indian Society of Mass Spectrometry in association with the Indian Society of Mass Spectrometrists. Professor Avinash Chandra Pandey, Director IUAC, who inaugurated the symposium, highlighted the varied and rising applications of mass spectrometry and the need to attend these facilities to the young researchers. He also reiterated about developing skills among the new generation to meet the next generation's challenges. As per Space.com, James Webb Space Telescope has found a galaxy just like the Milky Way, which is located 9 billion light-years away from Earth. Named Sparker, the galaxy is located in the southern constellation Volans. The galaxy was named Sparkler because it is surrounded by 24 shining globular clusters orbiting around it. Each of these clusters could contain around 1 million stars. Our galaxy currently hosts 200 globular clusters of its own. The James Webb Telescope view shows Sparkler as it looked when the universe was only 4 billion years old, or about a third of the universe's present age. According to the Science Alert report, if the newly discovered galaxy grows at the same rate that it should grow, the same way the Milky Way did in about 9 billion years. Now it's time for an amplifier. In Amplifier, we showcase the work, research and innovations of CSIR, ICAR and their dynamic national laboratories, famous for cutting-edge research and development, knowledge base in diverse science and technology areas. Also, you meet personalities who are enhancing the quality of life of citizens of India through their innovation and research in the field of science and technology. Scientists who are developing sustainable solutions and capacity building to fulfill dreams of all Indians. Gyan Ki Awaaz today we are featuring the launch of Green RTM by CSIR-CDRI Lucknow, a DNA staining dye and real-time Green RTM PCR 2x master mix held. The audio has been sourced from CSIR-CDRI official YouTube channel.
I request our inventor, Dr. Atul Goyal, to share with us the journey of Green R dye from lab to market.
Thank you, our director, Dr. Radha Rangarajan, for kind words. A very good morning to all of you. At the outset, I would like to thank all of you for your gracious presence today. And as you know that today our dream comes true when we developed our product from lab, and it is coming to see the light of the day today. So today I'll just give you highlights of the how we discovered this greener dye, taking from 2000 and 2020, where at that time the COVID pandemic was there, and we were struggling to get the import material so that we can do some biological work over there in every institutions. So the topic of today is the discovery of nucleic acid distilling dye, greener, for biomedical research and application. So I'll just give you a brief idea about the research work that is carried out in my lab particularly. So we have particularly in that development of new leads for natural sources for the treatment of osteoporosis and bone-related disorders. So in that we have developed a two molecule 399, which is a biodegradable bone implant material for bone regeneration, and another one is CDRI 1500, which is a fracture healing molecule, and we took up from hit to phase 1 clinical trial. So very soon we are going to do the phase 1 clinical trial for this. And another part that in the chemistry that we are doing is a diversity-oriented synthesis of new donor acceptor-based fluorescent molecules for biomedical applications, particularly to develop the technologies related to biomedical research. So in that category, we have developed this fluorescent dyes, particularly for staining DNA, lipid droplets, vacuole, and neuronal cell body in collaboration with our CDRI scientists. And also, we are working on these chemical sensors to develop the hydrogen biometal sensors like zinc, iron, and calcium for biomedical applications. So I'll just touch upon the technologies that we have developed in our lab in collaboration with Dr. Divya Singh, particularly for this CDRI 399, which is a new medicated bone implant material. So as you know, during this fracture, a doctor fixes the broken bone, particularly using this stainless steel plates and rods. So what we thought that can we have a kind of biodegradable implant material so that we can prepare. There is no need to do the second surgery to remove this metallic implant after surgery. So we tried to develop with Orthoregenics Private Limited, and currently this biomedical implants using 399 is in preclinical testing and validation by the Orthoregenics team. Another molecule is a CDRI 399, where the whole, I think, CDRI scientists are involved, particularly in the development of this molecule, especially emphasizing this Dr. Divya Singh, who has worked tremendously for this pharmacological activity of this molecule. And we have already licensed this technology to Tracker Pharmaceuticals, and we are going to start this phase 1 clinical trial very soon. So now I'll come to the journey of the discovery of this particularly greener dye. So I know everybody knows very well these dates, particularly when on January 27, 2020, the first COVID case was appeared in Kerala. And after that, in March 25, 2020, Shri Honorable Prime Minister Shri Narendra Modi ji imposes the lockdown. So at that time, there was the RT-PCR kit was the gold standard for doing the RNA quantification during the COVID-19. So when we look into it, that why there is a cost in the mid-year 2020, the RT-PCR cost per sample was around 4,000 to 5,000. So when we look into it, we found that the Techman probe, which is used particularly in RT-PCR, this is totally imported. And this requires this is a kind of Techman probe where we need a 3' end at a quencher, and at 5' end we need a fluorophore attached to it. So based on that, we thought that since we are working in this fluorescent chemistry, can we utilize these skills into development of this RT-PCR diagnostic kits? So we tried this by using several. So we give this assignment particularly to all these our staff, our students. So during that COVID times, everybody was staying at home, and then our students were working at bench. And several times they have been interrupted by the policemen due to this. But only the COVID research work is allowed at that time. So we worked in that area. So I assigned to synthesize these molecules to each and every student in my lab, and it was on the first batch and second batch, so that they can do as much as they can. So with the help of Dr. Niti Kumar, Ashish Arora, Dr. Reddy, and Dr. Shraddha Goenka again, we had a kind of PPP project model where we get a grant from CSIR to develop the indigenous diagnostic kit. So this was the necessity at that time to develop the RT-PCR-based indigenous diagnostic kit so that the cost will be cheaper in that manner. So our team has developed this fluorescent dyes and quenchers which is cost effective and patented. And this technology is, this Indico kit was tested at ICMR, and then we could able to get 100% specificity and 93.33% sensitivity. And this is a one step forward to the Atmanirbhar Bharat. So now come to this main project of Green R, where we have a collaborative project agreement with Biotech Des. When Dr. Shraddha just told me that can we have a kind of dye which can stain DNA so that we can use it in PCR experiments. So we set up a collaborative agreement, and then development of reactive fluorescent dyes and non-fluorescent tags for labeling of cross-linking project was initiated at that time during in 2021. So I think nucleic acid staining dyes are very crucial to do in various life sciences research, particularly developing this drug discovery assays, gene markers, diagnostics, and biomedical research areas. And this nucleic acid staining dyes are generally non-fluorescent in nature. When in the presence of DNA, it binds to dye binds to the DNA, and then it shows a fluorescence. And mostly only the imported dyes are currently available. So we thought that can be developed an indigenous substitute of these dyes, and only the 90% of the market is captured by all the imported dyes. And very recently, DNA binding dyes have been used for high resolution belt curve analysis, particularly for useful in the gene mutation detection. So these are the common dyes available in the commercial market. And we did the market landscape by using this Sadhguru and consultant, and they analyzed this, give this report. Then we see the import values of this, particularly it is increasing year by year. In 2017, you can see it's a 3.46 crores, and reached to 2020, it's a 7.10. And for 2021, it is a mid-year data basically. So if you double this number, that is around 10 or 11 crores. And the dominating dye, which is particularly, you can see this 78%, which is a green R dye, Cyber green, commercial dye Cyber green. So when we look into this patent of this Cyber green, it was done in 1994, and the patent was expired. So we had a degree of freedom to operate in that manner. So my student Sazia designed several molecules, and she could able to prepare several around 50 or 60 compounds in that. And the step of this green R is a 5-step process with 98% purity, and it is a very cost effective and stable at room temperature. And we have already filed this patent, and it can bind to nucleic acid of all kinds like genomic DNA, PCR products, plasmids, and RNA. And green R will further reduce the dependency of the imported material, and it is a step towards the Atmanirbhar Bharat. So, and this part was done by Biotech team, where you can see this green R sensitivity. It can nearly detect the 10 nanogram and 100 nanogram very easily. And when you benchmark this green R with the ethidium bromide cyber safe dye, you can see clearly this nice staining with green R in this case. And this was done by Dr. Shraddha's group. They have done this real-time green R PCR master mix, which is suitable for routine and sensitive qPCR experiments. And this 2x premix is capable for detecting a wide range of DNA, like 100 base pair to 1 kb in real-time PCR. And it can also be used as a real-time machine available and maintains the specificity and sensitivity of the reaction. So these are the amplification curves and benchmark with Tagara, and you can see this nice correlation with it. Further, this is the cost data of commercial DNA dye versus green R. So you can see this cyber green is costing around 40,000 for this structure. So we have developed a nice method to prepare this molecule in a cost-effective manner. And based on that, we could able to design several other molecules. We could have this green R out of this scaffold. And we have very recently, Dr. Shraddha has registered it into the GEM portal. So the journey was that licensing was done on February 16, 2022. And then technology of transfer was done on Technology Day on 11th May 2022. And further, This green hour was validated by several institutions like ISC Bangalore, CDRI scientists as well, IIT BHU, and ICR Labs, SIVA Private Limited, and the Biological Science Limited. So it is already tested. So as you can see clearly that how effective it was. We started this project in 2020, and basically in 2023 we could able to launch this. So how effective this kind of collaboration between academia and industry.
Now time for amazing science facts. The solar system was formed about 4.6 billion years ago. That's all for today. For any suggestions or feedback, do write to us at mediaforcommunity@gmail.com. This podcast has been produced by Ashish Tiwari.